In this video, we're going to solve systems of equations using a technique called substitution. So, when we use solve systems of equations using substitution. When we use substitution, essentially what we're doing is we're taking one equation and putting it into the other. So remember, systems of equations, we were solving them before using just graphing, and now we're going to solve them algebraically. So for example, solve, so here's the first one we're going to do. 2x minus 5y equals 20, and y is equal to 3x minus 17. So I want to solve these two equations here together at the same time. So somehow I want to combine these two equations and into one equation. So one of the things I can think about is when I have the y here, so right here I have y, and I know that y is equal to all this stuff. So all of the stuff in this box here is equal to y. And what I'm going to do is I am going to take all of the stuff in this box and plug it in for y. So I can really think of the first equation as 2x minus 5 times, instead of y, I can think of it as this whole entire box. So 2x minus 5y equals 20. And then if I take the stuff that was inside the box, this is a 3x minus 17. So we're talking about 2x minus 5 times the quantity 3x minus 17 equals 20. And so we're going to go about solving this. The first thing we have to do is we have to take this negative 5 and multiply it times the first thing, and also negative 5 times the second thing. So that's the first thing I'm going to do. So I have 2x, negative 5 times 3 is negative 15x's, and then negative 5 times negative 17. So I just want to remind you, right, you don't have to do everything by hand, so you can totally take your calculator out. So 5 times 17 is 85, and then if you notice, I have a negative here and a negative here. So when I multiply those two negatives together, I'm going to end up with plus 85 equals 20. And now on the left-hand side here, I'm going to put together the like terms. So the like terms are the 2x and the minus 15x. So if I think about, I have two of these x things, and then I'm taking away 15 of those x things, I would be left with minus 13x plus 85 equals 20. I want to get the variable all by itself, so I'm going to subtract 85 from both sides. If I do that, I have minus 13x equals negative 65. And then I'm going to divide both sides by that 13, negative 13, to get the x by itself. So negative 65 divided by negative 13 is actually positive 5. So x turns out to be equal to positive 5. But if you notice, in the beginning, my original problem here, they had x's and they had y's. So my answer needs to have x's and y's in it. So I found the x, I have to find the y. So to find the y, I'm going to plug back into one of the two equations up here. Now you could take this 5 and plug it into this equation or this equation. It doesn't matter which one. Personally, since this one's already solved for y, I think that's the easier one to plug it into. So that's what I'm going to do. I'm going to take y, and it's equal to 3x minus 17, but now I know that x is 5. So it's 3 times 5 minus 17, or 15 minus 17, or negative 2. So there's two ways you could write your answer. One way you could write your answer is that x equals 5 and y equals negative 2. Or you could write your answer as 5 comma negative 2 as that point. Because remember, what we're saying is the two lines that they intersect, and so therefore they cross at a point, and the point that they cross at here is this 5 comma negative 2. So to kind of recap the rules for substitution, and then I have two more examples we're going to do. So rules for substitution, they are the following. One, you're going to solve one equation for one of the variables. You'll notice that in my problem, that was already done for me. This was already solved for y. But if it wasn't, I could have solved it for y. And I'm going to do an example where we do that. 2, plug one equation into the other. Right? That's what we did here. I took this y and I plugged it in to this first equation. Then 3, solve what you get. That's what I did here, right? All this is me solving that equation after I plugged in. And then finally, find the other variable. And that's what I did here, right? I found the other variable. So if we do another example, so B, let's solve x equals 3y plus 1 and minus 3x plus 2y equals negative 10. So if I look at this first equation, right, it's already solved for x. So I can think about it as x is equal to all this stuff in the box. And so I'm going to rewrite this second equation, but I'm going to write it as I have negative 3, and instead of x, I'm going to think of it as all of that stuff in the box. Plus 2y equals negative 10. And then all that stuff in the box was the 3y plus 1. So I've taken this x equals the 3y plus 1, and I've replaced it in that new second equation. Instead of writing this x here, I've written all of this stuff, the 3y plus 1. So now I've got negative 3 times the quantity 3y plus 1 plus 2y equals negative 10. So negative 9y minus 3 plus 2y equals negative 10. And remember, this negative 3, it has to get multiplied times both things. So that's why negative 3 times 3 is negative 9y. Negative 3 times positive 1 is negative 3. I'm going to combine the like terms. So the minus 9y and the 2y are alike, and they're both on the left-hand side. So we're going to combine those. So that would give me negative 7y minus 3 equals negative 10. And now I'm trying to solve for y. So I'm going to add 3 to both sides. So negative 7y equals negative 7. I'm going to divide both sides by negative 7. So y is going to turn out to be equal to 1. And then I can pick whichever equation I want up here. I'm going to pick this first one, but I could have just as easily plugged it into the second one. It does not matter. And so if I take that first equation, x equals 3y plus 1, and now I take that, I know that y equals 1, and I plug it in here. So when I plug it in, I get x equals 3 times 1 plus 1, and 3 times 1 is 3, plus 1 is 4. So my answer is that y equals 1 and x equals 4, or you could write it as an ordered pair. Remember, in the ordered pair, the x has to come first. So it would be 4, 1. So let's try one more example here. So in my example C, I have minus 5x plus 4y equals negative 25, and negative 2x plus y equals negative 7. Now, unlike my last two examples, where over here in part B, right, it was already solved for x for me, so it was really easy to say, oh, x is equal to all the stuff in the box. Here, neither one of these two equations is already solved for a variable. So if I want to use substitution, the first thing I have to do is solve for one of the variables. And so I'm going to pick to solve for y, and I'm going to pick the second equation. And the reason I'm going to do that is because if you notice y here, it's all alone in that second equation. So it's going to be pretty easy to solve for the y there. So that's the first thing we're going to do. We're going to add 2x to both sides. And so we're going to get y equals 2x minus 7. And so now, just like before, I have y equal to a bunch of stuff. So I'm going to think of all that stuff as being in that box. And I'm going to take the other equation that I haven't used yet, this first one, and I'm going to plug this box, all the stuff that's here in this box, in for y in this first equation. So we're going to have minus 5x plus that first equation, just to rewrite it so it's right here to use. It was minus 5x plus 4y equals negative 25. So it's going to be minus 5x plus 4 times all that stuff in the box is going to be equal to negative 25. And all that stuff in the box is 2x minus 7. So our new equation is minus 5x plus 4 times the quantity 2x minus 7 equals negative 25. And now I'm going to distribute this 4, right? It's a positive 4, so it's going to get multiplied to both of these things. So I have minus 5x plus 8x. Minus 4 times negative 7 is negative 28 equals negative 25. Just like we did before, we're going to combine the like terms on the left-hand side. So it's just those x pieces. So a minus 5x and a plus 8x would give us a 3x minus 28 is equal to negative 25. I'm going to add 28 to both sides. So 3x. If I add negative 25 and 28, I get 3. Divide both sides by 3. X ends up being equal to 1. And then now I have to pick one of the equations to plug back into to find y. And it doesn't matter which one I pick. So I'm going to pick this one right here because I've already got y on the left-hand side. So to do that, I've got y equals 2x minus 7. So y is going to be 2 times 1 minus 7. 2 times 1 is 2. So this is 2 minus 7, or negative 5. So my answer is going to be x equals 1, y equals negative 5, or another way to write it is as that ordered pair, 1 comma negative 5. And depending on Alex, Alex sometimes might want you to write it as x equals 1, y equals negative 5, and sometimes it might want you to write it as the ordered pair 1 comma negative 5.